When you look at that gaff tool, did anybody notice that sequestration had trees on there and only dairy mentioned soils? And the dairy one actually had a spot in there to fill in your soil sequestration part if you knew it. The problem is, how do we calculate that benefit or soil sequestration that we have? The reason why they don't have it in there is because soil carbon is really hard to model. It's really hard to measure for all of those people. There's put your hands up if you've been out measuring soils, sampling soils in the middle of summer. Hard work. Questions that you'll likely get asked from most people is, how do I build carbon in my soil, or what causes, what makes soil carbon in my soil be there? So as Cam was just showing before, with trees, rainfall or climate is probably the key determinant. And in South Australia, it's rainfall, so that's annual rainfall. It's also temperature for us. So if you have low rainfall, high temperature, the ability to be able to keep carbon in your soils is probably much more limited. As we're going into a changing climate where we are having warmer temperatures and we're having wetter summers, that ability to decompose carbon is going on for longer periods. So it's really hard to then get that balance about having enough inputs into the soil and outputs out. The next component that we all seem to know about is your soil itself. So that ability of protecting carbon from decomposition. And in most soils, this comes down to clay. So the amount of clay in your soil, more clay, the more chance that it's going to associate with that mineral itself and be protected from decomposition. Silt is also important, as are calcium, iron and aluminium complexes. I will get this presentation to you, so it's got a lot of links and slides in there as well, and a lot of it is also in Cam's notes that he's got there as well. Really, the third thing that we all know about is management practices. So that's the part that we can control, and management practices come between that balance of what we put in and what is taken out. The question though that we get asked is, whenever we talk about carbon trading, we seem to focus on one part. And when we know for soil function or for good functioning soils, there's so much more than just greenhouse gas emissions. So there are 4 other functions that are important. Most people already notice that productivity benefit, the soil structure or the water story. So if we don't have healthy soils, we don't have good functioning soils, we can't capture, store water. There's also the nutrient cycling benefit. And of course, it's supporting that biological, the black box of the whole area, the part that we don't know about and why modelling is so hard, is those microbial interactions. And so that's about diversity, and that is also about looking at disease suppression in soils. And of course, when we're talking about carbon, we are of the realisation that decomposition, we're losing 70 to 90% of what we put in goes back as carbon dioxide through the atmosphere anyway. So we need to be mindful of improving our efficiencies. The question that always happens whenever we start talking about greenhouse gas emissions is that need to increase carbon all the time. In reality, probably 60 to 80% of our soils are going to be looking at maintaining carbon. So we're not going to be looking at losing them. So there is that area of some soils are able to increase carbon, but really we are looking at maintaining what we have, and so those footprints don't get larger. Decreasing carbon is what everybody wants to avoid. So it's just looking at those actions that participate in this. So what affects the carbon storage? We just quickly spoke through that before. Probably the key part in here is climate is out of our control. How we have those complexes, probably the really thing that we can really focus on here is that structural stability in soils. So having the structure, the healthy soils, you can have aggregation of your soils, that gives you a level of protection. So these are basically the theory of increasing carbon in soils. So down the bottom there, where we often sometimes have loss, is tillage or bare soils. So we can be in a losing carbon at that end, all the way going through from doing good management practice up to changing over to pastures. And in reality, I can't see too many cropping systems wanting to change over to fully doing pastures. So there's that reality about what your land use is and about what you might like to do. So Mel just asked if you can see a tangible increase in soil carbon with tillage practices. In South Australia, We haven't seen a big change when we've looked at it, but then again, tillage was adopted back in the 80s, 90s, so that change has probably already occurred, the bulk of it. In some areas where it's relatively new and you're going from a really low base of carbon and you're doing stubble retention minimum till, changes are definitely occurring. So again, South Australians adopted it pretty early. So we're ahead of the game. That big arc of changing carbon has probably reoccurred. So we can talk about management practices all we like. There's always tweaks on what we can do in management practices, but really it gets down to the principles of either optimising your organic matter inputs and minimising your carbon losses. So most of these areas, you're wanting to just have more input into the soil, be it grown, roots or shoots, be it looking at having more root exudates put in there, about importing organic matter from elsewhere. Cam had some really good figures on the cost of putting in compost and that. We can build carbon, but we also have to think about that life cycle analysis effect of what does it cost us to add some of these things and to change management practices. And as far as I know in soils, very little work has been done on looking at that life cycle. Minimising loss comes down to keeping as much of soil as we can and possible. There are a couple of fact sheets here that are available on the DEW website, and they just talk about what effect happens on management practices on each of those 5 different functions. So that can be a good starting point for a little bit more information. So we've got the reasons about what happens out there. When we actually take samples ourselves, we can influence what the carbon values are. So there are very determined guidelines for if you're looking at a carbon project. There are some very strict guidelines that need to be adhered to. But when we're just looking and we're talking about talking to farmers who might be interested in going into looking at their carbon changes, you don't need to probably go to the full extent of doing a soil carbon methodology. You might just want to identify some paddocks that might have that opportunity. Where you sample makes a difference. If you're looking at whole paddock, or if you're talking about stratifying down to production zones or into soil textural areas, you can do just a monitoring area in a paddock, so a 25 by 25 metre area. That can give you an idea of a change over time. Depths are important when we're talking about carbon concentrations. We're often talking our agronomic samples of 0 to 10 centimetres, and we use these still a lot as a basis for monitoring carbon change over time. But if we're talking about methods, we're talking about 0 to 30 centimetres, and that comes down to then having also carbon stock as a calculation in there. How you collect your samples and how you actually store them, believe me, can make a big difference. If you happen to collect moist samples and you leave them in your ute or in a warm lab for a couple of weeks, you can get some pretty good changes in carbon. So just be mindful that, like nitrogen, try and get your carbon samples off to the lab as soon as possible. And time of year that carbon is sampled makes a huge difference to your carbon results. So this graph here has got years down the bottom and carbon production concentration up the side. The orange line is the soil carbon change over time, and that dotted line just shows that microbial activity, how microbes respond to what carbon source is there at the time, and how there can be lag times between carbon changes and microbial activity too. When you have the least amount of growth or inputs in there and the least amount of microbial activity. I know a lot of pasture systems will often sample during spring, and that's fine if you want to continue doing that. It's just that it's that chance that you're going to pick up the most root growth or the exudates or the most microbial activity, so your variation is probably going to be higher in those. And the worst part about monitoring is that these variations fluctuate quite a bit through a year, let alone across time. So how do you know you've actually got a real change? And a real change often is going to be, you need to have a 3 to 5 year window, and you probably need to have 3 sampling points there to work out what your real change is. So it's a long-term process, and there is quite a bit of lag. So if we have a year like we're going to have now, we have low inputs, we have low ground matter, we may not see that change next year when we sample. It might be the year or the year after that that we can start seeing these carbon changes. So they can be long time frames. I think if you're monitoring, it's like the cost of things, it's efficiency. So if you're going to be doing carbon at the same time, nitrogen at the same time, you just do that, but you're mindful that that change, that variation, that variability might be higher than if you took it at a drier time. So it's a trade-off. If you're doing it for an ERF methodology, you definitely have to do it I would do it at the static time where you've got the least chance for that variation. It's hard enough to pick points in a paddock that are going to be similar, even if you stratify them, to be consistent in there, let alone trying to have those big changes over time. Carbon methods. Most people, if you're doing carbon testing at the moment, is everybody doing organic carbon Walkley blacks? Pretty much standard. Is anybody doing the ERF, the total carbons, or the total organic carbons? No. They're only needed if you're going to go into a carbon market. We've been starting to analyse all of our samples with it, so we get a bit of a rule of thumb about what Walkley black is and what the total carbon. So that's a LECO test. In South Australia, if you're on calcareous soils, be aware that the carbonate also gets burnt off in this reaction. So if we come from South Australia and you have carbonate soils, be aware you're asking for the total organic carbon test rather than just the total carbon. In this, they apply acid, burn off all of that inorganic carbon, the carbonate, before they test for it. We've been sending samples off to different labs while we've been doing this, and just noticing that there is a difference when you send them off to labs. So different labs have that different capacity of understanding calcareous soils. If you have a lab, stick with it. It's the same rule as soil testing, just stick with the same one you get so you don't pick up changes all of a sudden because of a change in a lab. This is probably the question I get asked the most from farmers. How do I tell if my soil has more opportunity to put more carbon in? Some rule of thumb ones. CSIRO have a model called Look-See. Has anybody used that at all to look at? Yes? It's quite a handy one because you're going into 0 to 30 centimetres. They're utilising all of the national soil information from their ANSYS database within a 100k radius of the site that you pick, so you can do it at a paddock or a farm scale, and it will give you an idea of what your carbon value might be. So it gives you a bit of a ground truthing value. Craig Liddicoat from Department of Environment and Water, he created some carbon stock maps. So this is based on all of the soil information back from the 1990s and 2010 that Dave Mashmat had done. So there is, the green map shows what the carbon stock is in 0 to 30. The brown map up there shows a modelled opportunity. So when we're looking at opportunity in carbon, we are looking at getting all of the carbon stocks across the areas, splitting them into benchmarks, looking at the difference between the 25th percentile and using the 75th percentile as a target. So these are very roughly modelled areas that will give you an idea of where there is high opportunity for carbon to be done. We've got some other things that are benchmarks, and these are probably much more useful for agronomic samples as well. The 0 to 10, the organic carbon Walkley black samples, they provide you with some carbon values based on the 0 to 10 on your texture. So if you got your carbon test result from your paddock, you can get your value, you can compare it to where you might like to be. So they're broken down into either agricultural districts, and if you have the opportunity, so these are again done on the percentiles, we're saying anything below that 60, 40% percentile mark, you probably have a good opportunity to increase. So it's that lower starting base. If you're above that 60 to 75%, the opportunity to change your carbon is going to be much harder and will probably include a lot more value. This year we've just pulled all of that data together. Instead of looking at those carbon values, they are based on rainfall zones, and this is probably more useful as a very rough rule of thumb for the outreach, the carbon farming outreach. They provide you with points, so there's 4 different soil types in there, and you can have a look at those using those benchmarks again, but they are a bit more rounded up figures. The lower limit is at 25th percentile, the midpoint is 50th. The target, the practical target, is at 75th, but in these ones we've included the stretch goal, which is the 90th percentile. So these are for those soils that are in between that 60 to 75th percentile that you think might have that opportunity to go a bit further, or you've got somebody who's invested and want to go. That will give you that little bit more stretch. These guidelines are basically those tables in a graphical format. So down the bottom there, you've got increasing rainfall, and up the y-axis, you've got carbon concentration, Walkley Black, in 0 to 10 centimetres. So each of those lines, the orange line is at 25th percentile, the black is the midpoint, the green is at practical target, the 75th, and the blue dotted line is at stretch goal. Couple of things, for all of those textures you can see similar patterns. Higher the rainfall, the more carbon. We know that, same as what can be grown. What's probably more interesting though is that difference in the opportunity line. So from that 25th, that orange line, to that 75th, that practical target, the green line, varies depending on your rainfall. So there's something that happens around that 500, 550 mark where those lines spread out, so that opportunity becomes larger and easier to occur. Like Cam's decreasing the yield there, you can see that above probably about 700 mil, that line flattens out. So rainfall becomes non-limiting, or the least limiting factor in our carbon values there. So when you're talking to people and they ask you, well, how much carbon can I expect to change in my area? This gives you an idea. So this is that difference in carbon value between the 25th and the 75th percentile. And all I've done is colour coded them. So if you're in the Southern Mallee, Northern Mallee, Eastern EP and Upper North, the chances that you're going to change between 0.3 to 0.5% carbon. So that's going up to that practical target if you're at that lower point. If you look at the green areas, that's where you're likely to go over 1 to 2%. So that's the lower southeastern hills and Fleurieu. These are quite different to some values that I've heard in carbon markets where they've been said that you can have 3, 4, 5% increases in carbon. So these are rules of thumb that you might be able to use to just ground truth or be a reality check about what could be expected in your area. Similar results when we look at that annual rainfall, so you can use that one. So these are all just based on generalised or average textures. This one might be it's more of a matrix about what those textures are like down by rainfall, and it's just colour coded to give you that idea if it's the smaller or the larger change increase. The numbers are rounded because we kind of averaged a lot of those things. So there is potential to go above that 2%, but I probably wouldn't go more than a 3% at the absolute most in probably the lower southeast with absolutely fantastic pastures. You wouldn't go more than a 4% change, okay? 2% I'm very comfortable with. From a very low point, so 25th percentile, assuming that to be a low point, you can expect to have a 2% change. If you're already along that way, like that midpoint, think of it as a 1% change. Just helps you get an idea about, if you're going to put anything into those calculators, what you might use as a figure for that sequestration value. These were just values, so they're more like benchmark values, so we don't have a change. We've got a lot of data for the management practice change, but they're not over long enough time periods to understand, so I don't have that data, but I am trying to put together something, and as soon as I do, I'm really happy to just send that around in a table format to everybody so you've got a bit of an idea. We've been asked a lot because we're seeing data come through from, normally we work in the 0 to 10 centimetre area. What does that mean if we're trying to convert this to 0 to 30? So I'm seeing a lot of data, so there's some really good projects going around. Ollie Madgett had started one with Farm Lab from under a Carbon Innovation Challenge where they've got carbon values across South Australia. Values come back in 0 to 30 centimetres. We've got no standards for it, so it's really hard to try and work out what that means. So these are extremely rough rules of thumb, but they might be useful for conversions if you're starting to get any clients who've got data and they're asking you what it means. I like to try and get it back to that 0 to 10, so then you could utilise those benchmarks. Probably the biggest thing that I always take home now about carbon is we can't change our climate, but we can change that capacity of our soils to stabilise carbon. So the real thought about long-term storage of carbon comes down to that stabilised carbon. We used to talk about it, carbon comes in 3 fractions, so there's that very active or particular carbon, which can build up quite quickly, also can disappear very quickly. So when we see large changes in carbon in areas, it's often that form that disappears, builds up and disappears. What we're looking for is this more stable, or what's now called, used to be called humus or HOC, now it's called mineral associated organic carbon. It's the organic carbon that is actually attached to the clay or the complex particle. So these little things are individual clay or silt particles, mineral particles. And if you are at the end where you have very little clay in your soil, think of most of these sands that have 1 to 2% clay in them. Carbon is basically free in the soil, so it's open to decomposition. So that risk of it being lost is pretty high. The next one across, you've got it bound to a particle, but it's exposed all the way around. It's not aggregated or stabilised in anywhere. It still is relatively free. The more you go along and having these in big bunches or complexes, the more stable your carbon. So we're looking for that stability. We always used to think that that mineral associated carbon had to be what was called transformed carbon, or to be microbial, decomposed and gone through. Now they know by using this like microscopy at the nanoscale, it can be fresh particulate matter, it can be root exudates, it can be microbial products, or it can be the processed carbon. It doesn't matter, as long as it's attached to it, it can be in there. So how we're thinking about carbon, it's got to be there for a long time. And when we're talking long time, we are talking 25 years. That ability to maintain your carbon inputs is really a big one, particularly in years like this year. If we're looking, this is a graph by Tim Herman from Dew, looking at maintaining carbon values at 1%, he would need to have a crop yield, you'd need to have a crop yield of 1.7 just to be able to have enough of that material to maintain that. The other option is the Clive Kirkby or John Kierkegaard work, looking at suitable nutrition to be able to build carbon. And this is as much about maintaining your microbes as well, about to perform their functions. Above and beyond what you need for your crop production, you need to have a certain ratio that's found in this long-term carbon of 80 kilos of nitrogen, 20 kilos of phosphorus and 14 kilos of sulfur. However, they also did have this part in one of their reports that in cereal-based farms where you have low stubble retention, and we're talking about 4 tonnes a hectare there, they did not see an increase in soil carbon stocks. So there's probably a thing about that tipping point, about being a bit below a critical point. If you go up to a high stubble area of 12 tonnes a hectare, so our lower southeast will be fine, you have a chance of enhancing carbon down in those areas. What can we practically do in these? We can identify where there are limitations to productivity or carbon inputs down the profile. A lot of it, in reality, if we're talking about practicality and cost effectiveness, it's about growing carbon on site. Is there anything that is stopping our roots? And Mel Fraser does a lot of work in this area. Ed does a lot of work in this area. If you can modify these areas to get more input into these parts, we can store carbon deeper into the profile. But we do need to be realistic and work out what the costs of these are. So in terms of that greenhouse gas emissions, in terms of real and actual dollars. So for carbon, your opportunities that you'll be asked for from your farmers is how much can I store? What affects my carbon? How much more can my carbon and my soil store? And you can utilise your benchmarks for that. Is my carbon limited in any way? So can you overcome anything in those areas to make them more conducive to storing carbon? Cam, do you have anything you might like to add from what you normally talk about too?
Yeah, I think you covered the key points really well. That idea of trying to understand the gap or your potential, I think is huge, and we need to do a fair bit more work to give us better ideas of that. There's SCARP data, which I don't think you mentioned, but I reckon that's really good local data because it does go down to 0 to 30 centimetres. So you can actually pull out stuff for your location and understand the variability that's associated with that, and the sort of ratios from 0 to 10, 10 to 20, 20 to 30, you get a bit of a feel for that because of that data that's being collected. the variability is huge, as you mentioned before. I've got some data on that because we actually went through as though we were doing that Q method of creating carbon credits and the steps involved in that, and just the variability at depth is really big. And the final one would just be about the test you mentioned, that we go from Walkley Black to the dry oxidation, the LECO test. But there's also other things that need to be added to do that calculation, because we talk about percentage carbon, but in being able to use it as a carbon credit, it has to be turned into tonnes. So that percentage has to be turned into tonnes, which means you also need bulk density, you also need gravel, and you're trying to do that at depths that are difficult to get those measurements easily. So it's a different testing regime as well, not just the one in the laboratory from Black to LECO, it's also other additional samples as well. The bit of stuff we did at home cost us over 20,000 to benchmark it. And the variability, and I'm happy to show people the results, the variability is just huge. It's really scary.
I think that's a really good point. Even in, we did some samples where we did down 0 to 30, 3 samples within 10 centimetres, so just moving over 10 centimetres, we had over 1.5% difference. This was in the southeast, just in that small area. So sampling is a really big factor for carbon, and it's about really interpreting those results and not just picking one result as a really key factor too. It's about having those trends over time, and time is 3 to 5 years, so expecting to see a change, taking that time. Looking after carbon for your soil's health and the functioning aspect is really, really important, but carbon farming projects as such, there are some areas that it will work, but there could be some other areas where it definitely won't work. So having a really good justification about what you're doing and where you're going.